Hello, fellow ex-citizens. Today we are going to continue our series to talk about safety of your electrical systems and your electrical connections, your house wiring. So the last time, if you recall, we talked about wiring, particularly like the choice of wires that you should be making when you are starting your house wiring projects or your small businesses, right? So today we're going to talk about something else. And the reason is I was watching a video of a fire, an ongoing fire that occurred yesterday in Liberia. And I think it was somewhere on the 19th Street where an entire church facility was gutted by fire. So it got me thinking. In the video, you can hear someone who's making commentary say that the grid electricity had just been turned on in that community. And then a few minutes later, the fire was observed. Now, it isn't clear whether the fire was caused by the grid electricity or LEC, as we call it in Liberia, right? So I'm not saying that this is caused by grid electricity, but I do have a first-hand experience of how the grid electricity is actually horrible. Well, it is horrible in the sense that at some point you get like the power coming through your circuits in your house is so low. Even the lights in the house are they come on, but they are dim, right? It's like you have sleeping light bulbs. Whoever has that, right? So only in Liberia you see such a thing, right? Well, maybe somewhere else it happens, but at least from your experience, especially coming from abroad, like you would probably only experience that in Liberia. The light bulbs turn on partially because the power being fed into the house is so low, right? And then suddenly it goes off and then comes back on, and then at some point that power comes in at a greater force than normally is expected. And those type of surge power, because they are unregulated, they are unstable, they can cause a lot of fire hazards in Liberia. And sometimes those fires will break out even if you have proper wiring. So I wanted to make that clear. And this is what I'm going to be talking about today. What additional step you can take besides getting a proper wiring. And this is not going to be something that is costly, guys. This is actually very cheap, but a lot of us don't know it. And even us who are knowledgeable about this, if you don't think about the Liberian context carefully, you will miss this point because you don't expect this to be happening. So this is what I'm going to talk about a little bit and shed some lights on, right? Uh, Okay, yeah. So here is it, right? So when we are talking about the power that is coming into your building, most times in Liberia, that power that comes into a building, it starts from maybe your generator house where you have this panel box, and this panel box has a huge breaker. So that is your main circuit breaker for your home or your building. And this is where most Liberians use that breaker switch to decide whether they want to source their power from their portable generator or they want to source their power from the grid. So sometimes you hear these electricians tell you about this is LEC, this is your generator, and this is neutral. It means no power going to your building. Now, that breaker in there, traditionally, those breakers do not have something we call a fuse. So those breakers, they have a specific amperage for that circuit breaker in there that basically means is that it will allow current at certain amperage to flow through that system, right? But if your system demands a greater amperage than that, sometimes the breaker will trip to save your system. However, if that breaker has a higher amperage than what is required for certain tiny devices in your home, that main breaker cannot protect those devices because the main breaker is usually sometimes around 60 amps for regular homes, but you can even have a 100 amps or 200 amps breaker because you may need that level of amperage running through your wires. So if you have a high amperage, even at 60 amp, not all of your devices will be able to tolerate that high level 60 amps. So this is why from that main breaker, that main panel, when the wire goes into your building, you also have these little circuit breakers, these small sub circuit breakers, and in there you have smaller you have these small panel boxes, and in those panel boxes you have smaller circuit breakers, and those circuit breakers feed individual loads in your house. For example, one circuit breaker will control certain number of lights in your kitchen. Another circuit breaker controls the lights in your bedroom, and another circuit breaker controls maybe some power outlets, like where you plug your fan, etc. So those circuit breakers, and some of them control where you plug your refrigerator, right? So you want to be able to have like multiple of those small circuit breakers to control individual power lines in your house, because those circuit breakers also they have lower amperage rating. So you'll find 15 amps, 20 amps, 30 amps, 25 amps, right? So now you see the main 60 amp breaker that can bring 60 amp of current into your main building is now distributed throughout your home or your building. And then those individual lines that feed individual loads or individual objects in your house, like your fan, your lights in the kitchen area, your lights in the bedroom area or in the bathroom area, and different outlets. Those ones are controlled by these small circuits that also restrict the amount of amperage that is being fed into those things. Why? Well, take for example your light bulbs. Some of those light bulbs, in fact, let's talk about just the outlets where you plug your laptop or your phone into the outlet wall, right? Most of those outlet walls, most of those outlets are rated at 15 amps or 20 amps. So you cannot be supplying something like 50 amps to those outlets. That is disaster waiting to happen. So this is why you need those circuit breakers. So now that we've talked about the main circuit breaker, which is in this example, let's take it to be like a 60 amp circuit breaker that is in your main panel box. The box where you go and control, you want LEC or you want generator. So you have a 60 amp circuit breaker there. I'm not saying that is what you always have there. I'm just saying for this example, let's take it as 60 amp. It's typical anyways. And then in your main buildings, you have a bunch of 20 amps, 15 amps, 30 amps little breakers that are distributed in these panel boxes in various parts of your house for large houses, right? Or even for a small apartment, you also have one small breaker there, hopefully, that controls, like, if you want to shut down the entire power into your apartment, you flip that switch, everything shuts down. Normally, you should have something like that. It's also attached to the meter that I think LEC gives you, or you sometimes have to install that breaker separately by that meter. However it works, but you know exactly what I'm talking about. Those are the smaller breakers that control the circuit maybe in your small apartment or the circuit in a small part of your house. So why do we why do we need a special kind of circuit breaker in your main panel box? The reason is that the regular circuit breakers in those main panel boxes do not protect your equipments down the line from overcurrent. That happens when your current basically exceeds the normal flow of current to your loads. These are things that can happen in Liberia because of the irregularity, because of the lack of proper consistency in LEC delivery. And this is something people don't understand. So because of that type of thing, you need something extra to protect your downstream equipment from getting burnt or damaged, right? So you need that. In stable electricity system, like in the US, there are things called fuses. And one of them is this small thing that looks like a glass and it has a wire running through it or a conductor running through it. This thing goes inside an object that you want to protect. For example, it could be something that you regularly charge, and because that thing has a very low tolerance of overcurrent, but the thing itself is expensive to replace, normally a manufacturer will put a fuse in that thing. One of it could be, for example, if you have a meter, that basically measures voltage, right? If like electricians use, right? Some of those devices have fuse in them because when the electrician tries to test a certain voltage and it's out of the current is just out of control, it's loose because they are doing these tests, or there's a short circuit there, so the current is high. Instead of damaging the technician's equipment, the fuse that is in this equipment is going to blow. Blow simply means the conducting wire that runs from this point to this point is inside this glass. If you look, you'll see something like a silver object in that glass. That conducting wire basically breaks when the current that is running through there exceeds the current limit. This fuse has a limit of 20 amps and is usually written on it and a 250 max volts. So if this thing is in a device, this thing is going to blow, protecting the device itself. So the only thing that gets damaged in that device is this tiny object, which is called a fuse. And you can replace this for something like 50 cents. Or in Liberia, it's a little expensive. It's going to cost you probably like $1.50 or $2 for a 20 amp fuse. And you can get this anywhere in those Ego electrical stores or some electric stores in Liberia. So that is the purpose of fuses. And this is what we're going to talk about here. So now in the United States, what you would notice that is common is that these fuses, and they have larger forms of them. So this is just a tiny one, but they operate on the same principle. They are just bigger than this. These fuses can be found in those main circuit breakers boxes or panel boxes, or here sometimes in the US they call them disconnect box, right? Electrical disconnect box or your electrical safety box. Safety because as soon as you pull the lever down to off, it shuts down all of the flow of current downward. That is what that box does, right? But then that box is of two types, the fused version and the non-fused version. The fused version is slightly more expensive than the non-fused version, and it is fused because it has one of these fuses in there or multiple of them, and they are larger, much bigger than this, and much more durable and solid than this fragile looking tiny thing, right? So those ones, they are called fused disconnect boxes, and they are intended to be used in industrial and commercial applications, not in your regular homes in the US. Why are they not recommended for your homes in the US? It is not that there is something wrong with having them in your homes, but they are not needed because the electricity that is coming to your homes in the US are mostly stable. And you do not need that extra layer of protection by having a fused disconnect box. However, in the US, in industrial setting, I think we talked about the same situation in the case of the wire. You need that extra safety because in industrial setting, it is not uncommon to have 200 amps of current flowing through wires. So to provide that extra protection of someone getting shocked and electrocuted instantly and dying because a piece of equipment drew a lot of current and they were not aware that that happened simply because the motor in that device or in that equipment has aged or something went wrong. Something got stuck in that motor and it drew a lot of current to force the motor, and that can cause electrocution. Those fused disconnect boxes are there to protect against those situations. So once that happens, your entire main circuit, the fuse in that fused disconnect box is going to blow, and then instantly, no power flows downstream to wherever people are working and need that extra protection. So in the US, this is where people use these fused disconnect boxes. In the homes, you do not need much of that because the power coming to your homes in the US are mostly very stable. So you don't need to worry about having those type of fuses in your circuit breaker. Now let's go to Liberia. And this is what I said, like even now, my apartment in Liberia does not have fused circuit breakers, and I'm going to replace them because I sat and thought about it, and I didn't realize that I should have thought about that. But because I'm not, like, I didn't think about the need for that, right? It has happened in Liberia where I noticed the current coming is very low. And then sometimes the current will surge like with that power, and you'll see funny behaviors, and even blew out a fan that I had brought from the US, and I was using a step up, step down transformer to basically power that fan, right? So damage that. However, it didn't occur to me until I sat and started thinking a little bit and said, but the things that are happening from that video, when I watched that video of that church on fire, and the fellow who was doing the commentary spoke about this fire was noticed like uh, a little after the grid electricity had come on in the community. I started thinking about those situations where the grid electricity sometimes comes with a rush of like overcurrent, right? Because they have no way of controlling that somehow, right? They don't have a stable way of distributing current over there. So I started thinking and said, wait a minute, there is something that must be done about these things, right? You can get it right, maybe a wire that can even take some of those high current, but even those wire will always have some limit to how much current they can take, right? Or even if they take that amount of current, actually, so the wire will transport that high amperage, but where it ends to your devices, right? It can damage your devices and cause fire in your devices. And sometimes when a wiring isn't even done properly, right, as we often see happening in some installations in Liberia, you have some loose wires that are hanging apart, and all it takes is a large voltage enough to spark the spillage of electrical current between those two loose wires, and fire starts. So whenever even the wire delivers that current at the end point, sometimes that's where the fire starts. If the wire is bad or the wire is not the right size and it cannot transport that current, the wire overheats, it burns the rubber around the wire, and fire starts also. So either way, fire starts because of some of these irregularities in the delivery of electricity in Liberia. So one way we can stop that is we take the safety used for industrial level, those fuses, and basically install them in our home. So at the level of the panel box, you should start thinking about this if you want to take the safety of your homes and your properties in Liberia seriously. Get yourself a panel box or a safety or disconnect box. It has many names. Get yourself those ones that are fused. Now, the disadvantage in getting those is that whenever there is overcurrent and the fuse blows, it's not a situation where the breaker just trips and then you raise it back on, you get current. When that fuse blows, the fuse is blown, you have to replace the fuse. However, do you want to, and if you don't have a spare fuse, this is where it can cause some headache for you. If you don't have a spare fuse and your fuse blows, you are done for that day. Like, you are not going to have electricity passing through that box until you go and get a new fuse and replace it. Now, the question may be, suppose we don't have stores here with fuses like that, right? So I don't know. I have not done the investigation to see whether the fused boxes are even sold in Liberia. I don't know. If anyone knows, please leave a comment in this video. If you go to maybe any of those popular electrical stores in Liberia, if you ask for fuse boxes, if they are there, let us know that they are there so that people can get some of these boxes, or at least know where to get a spare fuse, even if they bought their boxes from abroad, right? So that is one thing people need to do. And then if you get a fuse box, get some spare fuses that go with that box and keep it. So when your fuse blows, you replace it. Fuse blows, you replace it. So that is the small inconvenience you pay for having a fused disconnect box. But compare that to the risk you are mitigating, the risk of having your house gutted by fire, versus the inconvenience of, I ran out of spare fuses, so my fuse blew today. So my house is not on fire, nothing is burning, but tonight I may not have electricity. I'm going to suffer this heat tonight because I can turn my fan on or I can turn my AC on. Would you rather suffer even a couple of nights or a week of heat and no light versus your house burning? I think for me, the choice is pretty clear. So I think that is one choice we can make. A fused electrical disconnect box is better and safer in the Liberian environment versus a non-fused electrical disconnect box. Now let's go to the level of the individual circuits, right? The level of the individual circuits. Again, this one is again about the equipments that those circuits control. Mostly for light bulbs and things like that, overcurrent blows the lights. They're not much of a problem. They don't cause a lot of damages, so you are switching a bulb. That's the replacement you need to do. For things like refrigerators and other equipment, everyone who lives in Liberia, they know, they say every time you are leaving your house, disconnect all your equipment because LEC will, if this is the expression, LEC comes with force, it damages your equipment. That is exactly what they are talking about, the overcurrent, the unregulated current that LEC comes with sometimes. Sometimes it is undercurrent, sometimes it is overcurrent. Undercurrent is also destructive, by the way, it damages your equipment. But overcurrent is what really causes these fires and things like that a lot of times, much, much more than undercurrent. Undercurrent usually damages your motors because your motor receives power, lower power, and then it wants to operate at a lower power supply, and it damages that motor, right? So, however, the overcurrent part is what blows things up. Sometimes it does for sure damage your equipment instantly, as opposed to the undercurrent, which damages your equipment over time. Slowly, the motor starts to get damaged slowly. But the overcurrent damages your equipment instantly. And sometimes, in fact, on many occasions, if you investigate properly, in Liberia, some of those have led to fires. I bet some of them have led to fires, those overcurrent situations. However, if it doesn't lead to fire, it damages your expensive equipment. So instead of your equipment getting damaged, of course, your argument could be like, well, I can just disconnect my equipment in the house before I leave. What if you forget to disconnect your equipment on the day, right? So that's all I wanted to say today, guys. Be safe out there. Make sure to make the right choices. Get yourself a fused disconnect box or safety box and some fused circuit breakers in your home. Take care. Bye bye.